Now that you know, if you multiply number of if you multiply molarity by volume and volume by molarity, and you get mole, why don't you use this term and try to come with a solution or come with a way to figure how to create a diluted solution from high concentrated sources. Check this. The left beaker, let's call it 1, and this one we call it 2. The left beaker, it has a bunch of solute. So those are the circle are the solute. And we have solvent as well. So this is going to be our volume, and we call it V1. From the left to the right side, only thing we did, we added just solvent. Okay, so we added just solvent. Remember, solvent is not going to change the number of mole of solute. So number of mole for the solute stay as it is. The only thing you change, the total volume now is bigger. And molarity is equal to number of mole over volume. I increased the denominator or the volume, but N stayed constant. And you say constant. If N is constant, you say here, N1, call this one N2. N1 will be N equal to N2. You did not change it. You just added solvent. Why don't you write, the molarity? And we already have it in the top left. It says molarity is equal to number of mole over volume. So number of mole is going to be equal to molarity multiplied volume. Wherever you have number of mole, replace it by MV. I go MV1 equal to MV2. I will apply 1 and 2. I get M1V1 equal to M2V2. You will use this formula only and only whenever you are dealing with dilution. Only dilution. When we say dilution, you take, high concentrated solution, you grab a couple of, milliliter or cc from it, and you add it to a beaker or Erlenmeyer, whatever, and then you keep adding solvent to it. You started from high concentration, you ended with low concentration. So that's the reason we say you diluted the solution by adding pure solvent to it. If you want to know what's going to be the concentration at the end, or how much from the stock solution or the solution with high concentration you have to pick to create or make in a specific concentration, you will go with M1V1 equal to M2V2, and it will give you the answer. So check this. It says we want to make 60 milliliter from solution that has concentration of 0.2, and the source or the stock solution is going to be equal to 4. It has concentration of 4 molar. You go M1V1 equal to M2V2. It doesn't matter which one is M1 or which one is M2. Just give it a label, anything you want. If you call this one M1, then V1 is missing. Because you call 4 M1, then volume of the high concentrated solution, it will be equal to V1. Now, this one will be M2, so the volume for it will be equal to V2. I go M1 V1 equal to M2 V2, or initial volume multiplied initial concentration equal to final concentration multiplied final volume. I'm looking for V1, and as you see, just simply I take the numbers, multiply them, divide by the initial concentration, and it gave me 0.003 liter. Okay, let me write it here just to make it more clear. I had initial concentration equal to 4 molar or mole over liter. I want to know how much from that stock solution, how much from the stock solution I need to take. Okay. What do we want to make? We want to make a concentrated solution with concentration of 0.2. If I remember correctly, 0.2 molar or mole over liter. And volume, we want it to be equal to 60 milliliter. So you go M1 V1 equal to M2 V2. You're looking for V1. It will be equal to M2 V2 divided by M1. So you go V1 equal to M2. We have it 0.2 molar multiply V2. Okay, look to V2. I will use it as it is. I'm not going to transfer it to liter. Just simply say 60 milliliter, and I'm going to tell you why I did not transfer it to liter. I divided by M1, which is 4 molar. Okay. Now, highlight the milliliter. 0.2 molar, it has unit of here, molar. The molar will be done by molar, and you will end with milliliter as a unit of the final answer. So I got this one equal to point. We said, it's going to be 3 milliliters, which is equal to 0.003 liter. Does it matter if I transfer it, to liter and then use it? I'm talking about 60. Not really. It doesn't matter. Here they are asking, tell me how much I need to take from the stock solution. They did not specify exactly what's the, it was going to be the volume. It was going to be the unit for the final, for the stock solution. They just simply say, tell me how much I have to take. And in this slide, we want to molar, here molar, this one is molar, and we transfer the volume to liter. I need to use the right sig fig. We have 3 sig fig. This one will be liter across molar by molar, and it will give you liter. Okay. And forgive me, I think I put in, sig fig. Sig fig should be there. This one does not have actually digits. Digits after 2 is just 0.2. So we have 1 sig fig there. I multiplied by 0.0600 divided by 4.00. My final answer has to be with 1 sig fig. So now that we know how to use the concentration, how to prepare, diluted solution from the stock solution, I'm going to shift to some condition that you mix 2 or more compounds to each other, and you might get some precipitation. And I'm going to ask you, tell me how much from each solution I need to add to, for example, crush entire of this ion, that ion as a solid, or how much I need to add to, for example, 25 milliliter from the acid to neutralize it. Okay, so I'm going to take a base, I add it to acid, and I want to figure out how much from the base I have to add to the base to the acid to neutralize it. You will use concentration, but in order to use a concentration, you need to have a balanced reaction. Okay, always keep it in your mind. You have to go with a balanced reaction. Okay, so let's go after here electrolytes and ionic equations. What's the electrolyte? Electrolyte is an aqueous solution of an ionic compound. So you have an ionic compound. You dissolve it in water. That's going to give you cations, cation with a positive charge, and anion with negative charge. 2 particles with opposite charges. They will cancel, the total. They will cancel charge of each other. So the solution at the end, it will be completely neutral. There will be no positive or negative charge. And because we have some species, we have 2 species at least, then they can conduct electricity for us. We say that solution is capable of conducting electricity, and we call it electrolyte. So electrolyte is a solution that is capable of conducting electricity. Strong acid, strong base, or any ionic compound is capable of conducting electricity, and we call them strong electrolytes. If you go with, like sodium chloride, for example, sulfuric acid, hydrochloric acid, those stuff, they can conduct electricity for you, and you'll see a good actual current. We go with weak acid or weak base, weak acid like vinegar, or you go with what else? We have plenty actually, acid, acetic acid and other stuff. And like if you take those weak acid or weak bases, look at the right example. So if we go with acetic acid like this, or ammonia, NH3, these 2 compounds are weak acids and base, weak acid and base, and they are not capable of, they are not strong electrolyte. Why not? Because when you dissolve them in water, they will not go through 100% dissociation. Part of that compound or those compounds will go through dissociation. So you will have some unreacted stuff inside the solution. For example, check this. Acetic acid, when you dissolve it, you get H plus, good. It can conduct electricity for you. Acetate with negative charge, that's another good thing. But the starting compound, it has charge equal to 0. That means it's neutral. And because it's neutral, it's not going to conduct electricity for you. Okay. So any compound with 0 charge is not going to conduct electricity for you. Sugar will not conduct electricity because when you dissolve sugar, it will get dissolved as a molecule rather than going through dissociation. And if you are dealing with, partial dissociation, you will see some conductivity. If there is no dissociation at all, like sugar, then there will be no conductivity. And we say pure water is not going to conduct electricity for us, or sugar, for example, or ethanol. And assuming you're, like when we say pure water, you don't bring the tap water in your mind, because tap water, it has plenty of stuff in it. Pure water, it has only H2O. This is equivalent or molecular compound. It has no ion in it, and it will not, it's not going to generate, enough H plus or OH minus to conduct electricity for you. What is the problem? The problem is like when I dissolve 1 mole from sodium chloride, I get 1 mole from chloride ion and 1 mole from sodium ion. So I get 2 moles, 1 mole cation and 1 mole anion, and that's perfect. I can have the maximum conductivity. But when we compare it with the acetic acid, it will give us some. I'm not saying 1. It will give us some, some H plus. It's going to be less than 1 mole of H plus. And here, again, equal to number of moles of H, we will have the acetate. So 2 particles with, positive and negative charges that they are capable of conducting electricity. They are going to be less than 1 mole. And I also have a compound that is neutral, has no charge, is not going to conduct electricity for me. And that's the acetate or the starting compound. Okay, so always I have something from whatever I added sitting or flying inside the solution and has no charge. That means it's not going to go through dissociation, so it's not going to conduct electricity for you. Okay. Now, we're going to start the ionic equation, and I'm going to show you what's the meaning of ionic equation. Let's assume you started with homogeneous mixture, and the homogeneous mixture is Ki. You add it to lead nitrate. So you have a homogeneous mixture. How do I know it's homogeneous mixture? Because it says aqueous. It says aqueous. That means that compound is completely soluble. Okay. So if you see here, it says aqueous means soluble. And then I added to another compound that is lead nitrate is soluble, and I got 2 products. I got potassium nitrate is soluble, but I got 1 product that is lead iodide insoluble, and it will crash. And as you see, the solution turned cloudy. Anytime you get a cloudy solution, that means something is not soluble. Even even if you say like, oh, it's not much, still you can see it. You can see the solution turned cloudy. That means there are some particles are flying inside the solution, but they are really tiny. So you don't, they don't sit right away at the bottom of the flask, but you have to give it enough time. Okay. If I start with potassium iodide and then this time I add sodium chloride to it, again is homogeneous. When I look to the product I got mixture that is completely homogeneous. Okay. I don't see any solid or nothing crash at the bottom of the flask. In this case, we say if all the products are soluble, if all the products are soluble, then we say no reaction or nothing happened. No reaction or nothing happened. Why no reaction? Because the only thing that you did, you took a completely homogeneous mixture, you add it to another homogeneous mixture, you got a container that it has now more volume in it, more homogeneous solution in it, and you have potassium, iodide, sodium, and chlorides in there. They're just flying, they are completely soluble inside the solution. They will not give you any product until you get rid of the solvent. When you evaporate the entire solvent, now you will have mix of anything. You will have Ki, starting compound. You will have sodium chloride, again, starting compound. Then you get KCl, this is 1 product. Then also you can get, sodium iodide. That's going to be the 2nd product. So as you see, I will have all of them at the same time. Which one is dominant? I have no idea, but I can tell you that, for sure you'll have all of them, for sure. And that's the reason we say nothing happened. Okay, nothing happened. Chloride will get paired with either potassium or sodium, because the chloride, it has a negative charge. So you have to cancel negative charge of sodium, the chloride, by something. And so chloride is going to grab whatever around it, either sodium or potassium. So technically there is no selection there. We have some rules when it comes to solubility. We can use those rules to predict whether we're going to get a soluble solution or we get precipitation. If you are dealing with a compound that has 1 cation from group 1, so your cation is something from group 1, or by chance is ammonium cation, NH4. Okay. So if you have cation that is group 1 is like lithium, sodium, potassium, cesium, rubidium, those stuff. And if you pair them with any anion, they will give you a soluble compound. Next, if you go with an ion that is nitrate, acetate, chloride, perchlorate, they will be soluble. Heavy metals, okay? heavy metals most of the time are insoluble. So if you go with, heavy metals, there's high chance, you will get some precipitation, but they will be soluble if they get paired with stuff from number 2. So if you pair, for example, lead with nitrate, will be soluble. Okay, so they will be insoluble, but if they meet any anion from number 2, they will be soluble. Okay. Chloride, bromide, iodide, or the halogenated elements, they are group 7 of the periodic table. They are soluble except when they see the heavy metal. They will be soluble except when they get paired with heavy metal. Then they will be insoluble. Okay. So if you pair silver with chloride, you get solid or precipitation. Stuff like carbonate, sulfide, or oxide, hydroxide. As you see, there are plenty. Usually they are insoluble. Forgive me, what's happening here? Clicking this. They are insoluble, and we have some exceptions. And sulfate, sulfates are soluble except when they go with calcium sulfate, strontium, or barium. In that case, they will be insoluble. Technically, you are meeting element from group 2. Okay. If you pair sulfate with element from group 2, they will be insoluble. Okay. I don't expect you to know 5 and 6 when it comes to the exam. I will try to avoid 5 and 6. But for the online assignments, because you do have access to the slides, you can look to the slide and figure whether you are dealing with soluble compound or not. But for the exam, I want you to know 1 to 4. Okay, 1 to 4, you need to know them for exam.